Hey, how you doing? So one of the things we're trying to look at here is why do things mix the way they do? And so to look at it, first of all, what I have here in this experiment here is just some shaving cream, which is mainly stearic acid, and some red 40 food coloring. And as you can see, I put the drops on there. I had to physically stir it in, and it doesn't dissolve well. There's something about the shaving cream that doesn't allow the red 40 to dissolve. Well, if I take a look and I move this, here is the shaving cream um, up here. This is the shaving cream. This is stearic acid. And essentially what this is, all this long chain are carbons and hydrogens. And this whole thing right here has electrons really evenly spread out. And so when I take a look at this, all of this right here, these are just evenly spread out. Okay, so I'm just going to try and draw it around there. And you can see there that it's just evenly, very non-polar, nothing to grab onto. On the other hand, when we look right here, here's oxygen and carbon, hydrogen. Whenever we have these, it's like having a somewhat negative side and a somewhat positive side. It's like a mini magnet with two poles to it, but that's only a small part of it. On the other hand, let's just take a quick look now at the red food dye. Here's the structure. Look at all the places that has the polar, somewhat negative and somewhat positive. Any place where you see that oxygen and hydrogen, right, it's extremely polar. Even there's a plus and minus charge. All of these places here are going to want to grab onto here, but it can't really grab onto anything else. So it's just kind of stuck. Doesn't have really any place to go. Now, on the other hand, let's see if we can move this to the next slide. Maybe. Okay, we're going to hit pause here. Okay, now, same game, sort of slightly different story. So remember, we're with our food coloring, right? And we have all these really polar, like unevenly distributed electrons in all these little places. And they're just all over the place, right? Now, for some reason, it's really stuck to the paper. Well, what is it about that paper? Okay, well, let's look. Hey, look, again, here's the really cool part. More places on the paper, tons of places here that are kind of negative. These are everywhere where you see these O's right here. It's like a mini magnet, right? It's kind of like hogging electrons. It's unevenly distributed. And there's tons of them there. Paper. This is what makes up paper. It's very polar. Take a look, and again, now there are all these little dots right here. These black parts right here. This is nonpolar, so there is quite a bit of that, but there's a mixture. But again, a lot more. So given the choice, the food coloring says to the paper, kind of, hey, I've got more places I can cling to. Likes dissolve likes. Polar and polar are going to stick together. That's what's going to help us figure out how to hydrodip.